Hello, thank you for the introduction. Right, so yeah, so I'll be talking about generating data with large language models and then having humans in the loop while you're generating it. Yeah, I'm a machine learning researcher at Cohere. So some basic definitions, you have your large language models, it's all the kind of hype right now. There's basically it's just like there's text input and then your language model, and then you can either have text output, which is like generative or autoregressive, and then you have your like a vector output, which is like a numerical representation, which is embedding. And then the technique most people use to kind of for inference with these models is prompting or few-shotting. So you give it either instructions or instructions plus examples, and then it kind of completes, like follows the pattern that you're kind of showing it. So the basic terminology is a prompt is kind of what you instruct it to do, and then the completion is the response from the model. So in this case, it's like a one-shot prompt, because it gives one example. So then kind of in the space of companies that are using these large language models, let's say with like GPT-3 or Cohere API, like you have your Copyright, your Jasper, et cetera, like all these different marketing. I mean, there's a wide variety of companies. Most of them kind of usually in the beginning, they start with like few-shotting or prompting. And that's kind of like the introduction of a lot of, to using these language models. But what tends to happen is they exhaust the capabilities of just using kind of the baseline models very quickly. And not only that, so like they reach some kind of like performance ceiling, but running these productions and models, running these models in production, so actually doing kind of inference at scale is actually very expensive, and usually with like your very large language models like the 173 billion parameter GPT-3 models, Cohere like 50 billion parameter models, they're very slow to run in production, so you have high latency. But yeah, in general, it's very expensive to actually, like you can prototype with prompting, but actually deploying it like deploying a very large language model with prompting in production is very expensive. And so they usually hit a wall. And then the other issue with prompting with these like very large models is that they often suffer from reliability issues and safety issues. They're very easy to, it's very easy to get it to generate kind of unsafe responses or something that's not considered, like let's say the company actually serving it, they don't want to generate those kind of things. Additionally, also just prompting alone is a very shallow moat for most of these companies. It's very easy to reproduce prompting-based outputs. So it's in terms of competitive advantage, it's not. It's insufficient to be like if you're competing in the marketplace. Yeah. So in general, there's also like niche use cases. A lot of prompted models they don't perform very well. So that usually leads like it necessitates kind of like fine tuning with these models to get better performance. So then with fine tuning, you need data, and so that's usually the issue. Like that's kind of one of the blockers for running kind of these fine tuned models. And let's say for niche use cases, you often need expertise to generate that data, and getting that expert kind of labeled data it can be very expensive. If you're doing in-house, you have to kind of hire people, or you have to use like your own expertise. It's very slow to scale. And if you like with different outsourced solutions like Surge or Scale or Human Loop, getting annotator responses is often very expensive if you want like high quality, which is necessary for getting good performance with these models, like fine-tuned models. So, for example, it could be like $3 to $6 per sample, and you need every iteration, let's say, batch of like samples for a fine tune. You need like hundreds of these samples to run a fine tune, and then the turnaround time is often long, so it's very slow to iterate when you're trying to. You want to kind of do a quick fine tune to prototype an idea, but like the bottleneck for that is often like it's slow and expensive. So the solution is. So like what's the solution that kind of I developed at Cohere and we've used in, let's say in our instruct models and like various other solutions is you can actually use language modeling models themselves to generate data. So kind of like the 4 steps is you would generate the prompt, So let's say in this case, like explain the moon landing to a 6-year-old. So that would be actually generated from a language model, and then it would generate several and then you feed that prompt back into the language model, and then it would generate several responses. So let's say in this case, it'd be like 4 candidate responses, and then the human, instead of writing all this, so like usually the time and expense comes from the labor required to write the prompt and the responses, but now all the human annotator has to do is just select the best response. So like the supervision is kind of reduced to just like ranking, let's say, or just like selection, which is very fast and cheap. And then once they select the best response, then they can perform edit. So writing something from scratch takes a lot longer and requires a lot more kind of labor than just editing. So having synthetic data or generate data with human just reduced to kind of selection and editing, that becomes much more feasible, and it's faster and cheaper to actually create like a data pipeline with that. And this is actually a technique we used to prototype our instruct models, which we've like deployed in production now. So in general, like the cost reduction is pretty significant. So like what's an example? So this is kind of a prompt. This is for like story generation or like dialogue generation with a character that you kind of specify. So the prompt for the character would be, you give a name, there's like character headlines, some like basic descriptions. Like in this case, it's some detective in New York City. He's like certain age, height, etc. Then he has like certain background, etc. So this is like a prompt that you would feed to one of these language models. And then so this is generated. In this case, this is actually the Da Vinci model from OpenAI. It's like 175 billion parameter model. So it's like the dialogue would be, so the whole dialogue is generated. So it's like, where did you grow up? I grew up in, so this is like a conversation you'd have with this character. And so the response is pretty generic. It's kind of like, I grew up in Chinatown, New York City. Father was Chinatown gangster. The mother stayed-at-home mom, etc. So yeah, this is what's generated from a 175 billion parameter model. And this is generated from a fine-tuned 6 billion parameter model. So it's, let's say, maybe for time, I won't read out like all the responses, but it's like what made you decide to become a detective? I saw how hard detectives had to work to solve cases. I want to help people and make the world a better place, etc. So just in general, there's like 2 orders of magnitude decrease in the size of the model. So like you could run this very feasibly, like cheaply in production, and similar output quality to the baseline 175 billion parameter model. On a very niche use case. So this is something that usually requires data. So the process for kind of generating the examples to do this fine tune, it was kind of this in consultation with another gaming company, and so that was all done synthetically. So that's basically concludes the talk. Okay, and then I guess questions I can leave to the end, or like right after this. Okay, thank you.